Hi everyone, this is Ram, and my research topic is mitigation of DDoS attacks in 4G mobile networks with the help of Honey Cloud and hybrid network intrusion detection system. So here is the 4G architecture. With the emergence of a new technology in communication, it resulted in many innovative security threats as well. And 4G mobile network uses IP-based communication. It's an open architecture, and in this kind of scenario, the more vulnerable it is to all the security threats. So which has been exposed to various internet-based attacks and security risks. So in this like this 4G architecture, access, core, and control are the three main parts, and ETRAN contains E0 B, and it acts as a LTE base station. It takes over the radio management functionality. So when E0 B is connected to evolved packet core, and, and then it is connected to the internet and applications and IP networks, etc. So LTE operates in lower 700 megahertz and upper band of 1700 or 2100 megahertz frequencies. 4G LTE service providers use both lower and upper bands. LTE is compatible with both the versions of duplexing, which are transmit and receive methods. So time division duplexing and frequency division duplexing are joined together with the downlink modulation scheme and orthogonal frequency division multiple access to achieve maximum peak downlink data rate of 100 Mbps. So here, what is a DDoS attack? So DDoS attacks are nothing but it's a simple mechanism. It is very simple to implement and launch. And is very straightforward. Attacker tries to exhaust the system resources by sending flood of messages to a server like UDP, TCP/IP packets, and the attacker tries to consume all the resources like CPU cycles, memory, file allocation, network bandwidth, etc. So in such a way, he can block the data connection of the subscribers connected to the server, or he can reduce the victims throughput to almost zero. And as you can see in the figure, it is very easy. The attacker tries, the attacker compromises other internet things and attacks the victim server with flooded packets and makes the victim server overwhelmed. So in LTE, so what are the MAC layer security issues? So the number one would be illegal operations to access network services, user tracking based on the temporary user identifiers, signaling messages, etc., and illegal access and usage of security procedure keys to access network services, and malicious modification of UE parameters to lock out a UE from normal services, tampering of E0B broadcast information, eavesdropping and modification of packets, denial of service attacks on the UE, or ENB, and data integrity attacks using replay technique. So how the DDoS attacks are happening in LTE? So first, the first thing is during a handover. Handover is a function carried in 4G LTE by E0 Bs. So during the handover, a new CRNTI, a temporary UE identifier at the cell level, is assigned to the UE via the handover command message. A passive attacker can link the new CRNTI and the old identifier unless the confidentiality is not secured, and the attacker can be able to track the UE over multiple cells. So the location tracking is an issue here. And the 4G LTE network is an IP based network with high dynamic devices with an activity period from a few seconds to hours. The end devices could be diverse and involve a heterogeneous range of users. A malicious radio listener can cause a conflict at the E0 B and create service problems for the legitimate UE. And in the discontinuous reception period, the UE can stay in active mode and can turn off the radio transceiver at the same time to save power consumption. During a long period, UE is still able to transmit packets, and that is a potential security hole. Attackers can inject CPDU packets and cause DDoS attacks for the arriving UEs. Attacker can also send fake buffer status reports to ENB. This will change the behavior of algorithms. ENB believe that there is a heavy load and stops accepting newly arrived UEs, and thus the attacker succeeded in using all the resources and making the service unavailable to the legitimate users. So here is some related work done in the past by the researchers, and the first thing is ASEAN algorithm. So it is a congestion notification algorithm, and it has cons like each of congestion signal by the receiver is required, but the congestion is handled by the sender. So the attacker can manipulate things in this thing. And the second one is Android app showed failure of firewall. So and in this scenario, when once the firewall is damaged or compromised, it can shut down the entire system. That's the main major drawback in this approach. And the third one is the proxy server with secret IP. It has a very good success rate, but the problem here is the installation costs and the high management and maintenance. And the fourth one is a firewall on the internet border. This approach is successful in IP filtering, but the problem is with the session table of stateful firewalls. In SMTP spam implementation of distributed security architecture approach, failure is encountered when a failure is encountered, it is very difficult to restore the system. And the signaling DOS detection algorithm, the problem here is the algorithm is not yet tested, so it's not a real-time approach, not yet. So DOS detection algorithm based on inter setup time and number of requests per minute failed to detect the attack by default. And deployment of security gate walls, firewalls, intrusion detection systems and intrusion prevention systems has got a low performance and lack of transparency issues. And in GI or SGI carrier grade NAT CGN solution, peer-to-peer applications are very difficult to set up. So here is some related work regarding the honeypots or honey nets, honey clouds. So the first approach is IP traceback for flooding attacks on internet threat monitors using honeypots. So using honeypots, it gives an option of IP traceback, but the problem here is the data centers are heavily loaded, and bot detects amplification attacks like DNS amplification and all, but it gives the same value for every protocol. So the problem is with every same value. And Honeywell mitigates outbound traffic, but it couldn't control the internet network. So therefore, the internal network is not safe with the Honeywell approach. And the visualization of actionable knowledge to mitigate DDoS attack, it is not practical. Flow-based worm detection using correlated honeypot log procedures. Attack patterns are registered, and but the problem is it has a low detection ratio, and there is a loss of information as well in this approach. In Honey ID, the virtual system with unallocated IP addresses. That's the approach, but the problem here is it does not support the delay command. So here is the proposed method for the research topic. So the main concept or the main reason behind this proposed method is to implement security measures at every step in the architecture. So when the internet is coming into the network, at the first stage, it should be that there is a firewall with deep packet inspection ability, and here the incoming traffic is filtered, and the legitimate users are passed through. The illegitimate users or the requests, they're saved in the log server for future use. Um, and here ingress filtering is used, and it is proven that ingress filtering is successful in detecting the illegitimate users or the requests. So after passing, and here to differentiate between the legitimate and illegitimate users, we use an algorithm, and it is very strong. So based on the algorithm, the network is passed through, or the network is, or the details are saved here. Illegitimate users say details are saved here, and then it goes to the router. So router, what it does is it redirects the legitimate and illegitimate users requests. So all the illegitimate requests, they go to the honey wall or the honey cloud over here. So before entering the honey cloud, there will be a fake IP assigner. So what it does is it will change the IP addresses of the honey subnets frequently. So in that way, the attacker will never get to know the real IP addresses of the honey cloud. And the legitimate users, it goes to the honey cloud, and there we use honey cloud here so that the attackers, so that we can get some information about the attackers activities, so we can get to know the pattern. So more information about him. So, and the main success here is he shouldn't be knowing that we are using a honey cloud to trap him. So he shouldn't be knowing that. So that's the reason we are not using the real IP addresses of the honey nets here. And all the information we get through the honey cloud is saved in a server, and all the legitimate EO requests, they go through HNIDS, hybrid network intrusion detection systems, and through that it goes to the DMZ, dematerialized zone, and through that again there will be a firewall between the main internal mobile network and the DMZ. So, and again in the internal network, in the internal mobile network, there is a another HNIDS. So, and all the information or all the intrusions which are being detected are saved in the log servers. So in this whole approach, every firewall, at every stage, the security measures are implemented, and with the use of honey cloud, the detection rate is gonna be more high, and it's a proven fact. And at the firewalls, the algorithms should be very strong in detecting the intrusions. And these are all the references I have gone through regarding the literature review and the research method specification. And here are a few more. Thank you.